Good morning,
Good morning,
and welcome to Family Jewels. I am Colton Bartell,
and I'm Audie Bartell.
and we are both graduate gemologists here at Suzann's Custom Jewelers. And today we are talking about a stone that we've actually covered a couple of times, but we keep getting more and new and better information about them and more exciting things to share, so we figured we would discuss them again. So we're going to be talking about lab-grown diamonds and some of the benefits behind buying those, and then kind of maybe putting to bed some of the wives' tales behind them and stuff like that. And
So wives' tales.
Yeah.
So
yeah.
that's
In
wives,
there,
not wise, right?
yeah, not wise tales. So, anyway, we're going to talk a little bit about the process, how they're made, and discuss why that is a benefit, not only to you, but to the world, and basically the ecosystem and all that good stuff. So, take it away.
Take it away. Okay, so, and we kind of covered this before, probably first lab-grown diamonds were done in that 52, 53
1953, yeah.
era. And
Just
a
this
little bit of, who did it first, but original story I heard is...
Some whodunit?
Yeah, the original one I heard was General Electric. But it took them for like forever to get it to a point where they were actually gem quality and of any size. And then after they did that, it took even a little bit longer yet to get it to where it was actually reasonable price-wise. I mean, there for a long time, the lab-grown diamonds, gem quality, were actually more expensive than a mine diamond, which didn't make a whole lot of sense to me. But somewhat has changed, and like Colton told you at the start, there are more benefits rather than detractions like it used to be.
Yeah.
So I guess one of the things that, and I guess you're going to get into maybe how they're made or whatever, but one of the things is, for the most part, you're not going to dig up any ground to get to these. Where
right.
A mine diamond, you're going to do that pretty much whether it's alluvial or site, where it's at a diamond pipe or whatever. And the latest thing that we got, it takes 98 square feet of
excavated earth to find 1 total carat of diamond, and to grow
we don't dig anything.
Yeah.
So then the other one is carbon emission, since everybody's talking about carbon emission or whatever. And the mine diamond, basically, they figure it's 2,011 ounces per carat. So
of carbon emission.
Yeah.
So this is from the equipment running, from
whatever. Yeah.
Energy used to basically...
I don't know basically if it'd be...
unearth
right.
the diamonds.
Right.
Yeah.
And on the lab grown, it's basically zip. I mean, it's
0.001 ounces.
Yeah. So
per carat.
That's smaller than a carat diamond, weight-wise. Right?
Yeah.
Would that be right? Yeah, that'd be
Yeah.
right.
So you're talking basically what the carbon that you're putting into the stone is about how much you're going to emit. So you're kind of offsetting it a little bit. Yeah.
I never thought it that way.
Yeah.
Actually...
So you're virtually not having a carbon footprint.
No.
Because what you're putting into the stone, that's taking out of the atmosphere, or it's using up carbon.
It's
using up that much carbon. It's using as much carbon in the diamond as what it's putting out.
Yeah.
And so it's kind of an offset.
And then the other thing is water usage, where...
which is a huge deal, especially where these are mined at.
Yeah.
Because most of these places where these diamonds are mined are really remote, and a lot are desert regions
Or
third world country where
frozen.
it's yeah.
I mean,
So water
Russians,
is a rare source.
The Russians are going to be frozen, and the Canadians are going to be frozen.
Yeah.
So,
but for the most part,
you got to heat the water just to use it.
Yeah, where these mines are at, water is scarce.
It's arid. Yeah. So, anyways, it takes 127 gallons if you do mine diamonds
to produce one total carat,
right.
Not just a carat stone, but one total carat.
And it takes 18 gallons on a lab grown to produce a carat.
Yeah, that's just amazing.
Yeah. So those are kind of the little deals that affect environment.
I think people use more than that in a shower.
Well, at least in a day.
Yeah.
Yeah.
So, yeah.
But those are just kind of maybe a little bit of environmental impact because I think at one time this was probably a little more. I mean, I think they've gotten a lot more efficient in how they're making these and producing these, and that's why costs have somewhat come down. And
the efficiency,
they can do more than one diamond at a time now, and
the efficiency has gone up. The control of the environment around the stone has improved, so we're getting colorless and near colorless stones versus the brown and yellows that were prominent, when they first started. Obviously, this isn't a colored picture because this is from the early 50s, but you can see...
They had color back then.
Well, they had color back then, but it didn't make it in the photographs. So, you can actually see these are little tiny diamonds, synthetic diamonds that are being poured out here. So, the Swedish were actually the first ones to do it, but felt that the process was too expensive and just basically not economically viable, and so they didn't publish a paper about it and basically state that they had done it until 2 years after GE had actually said that they did it. But GE had actually done it a year after the Swedish had done their first synthetic
Yeah, I know,
stones.
it's just kind of a...
It was kind of a convoluted thing of...
Actually, I met one of the guys that was the GE, and I can't remember his name. Wasn't him.
Oh.
Oh, he was a doctor something.
Well, I don't know. That's the only one
Seemed
that they
like
mentioned
it started
here.
with a D.
Well, there's a Dr. Tracy
No, wasn't
Hall.
him either. Oh, I can look it up later. And actually, where I met him at was the first gemological symposium they had in California.
Well, so the main process that's being used currently for
There's two.
Yeah, there's two of them. The one that we're getting diamonds from, that process that's being done is HPHT, which is basically recreating Earth's atmosphere where the diamonds would naturally...
Let's go conditions. I don't know about atmosphere.
Yeah, conditions.
Yeah.
Because diamonds, unlike most of those gems out there, are actually forming in the Earth's mantle, not in the crust. And
so it's lower.
Yeah.
Deeper.
This is where rock is still molten, and the diamonds are actually forming in that and hardening within that molten rock.
They're crystallizing there.
Yeah, and so when they come to the surface, they're actually coming up through basically a cold volcano. They're coming up through either a kimberlite or a lamprite pipe, and basically that...
Which hasn't happened...
in a long, long time.
Yeah, I'm trying to think now.
But a lot of this is, these mines are becoming depleted. There's no new sources coming online. Matter of fact, there's going to be mines shutting down here soon because lack of commercial viability. And so
actually, it used to be the largest mine is supposed to close in 2020.
Yeah. So the need for these stones is growing, and the appeal of these stones is growing. When we talk about these environmental factors that come into play, you're not disturbing any ground, you're using a fraction of the water, and you're basically not releasing any pollution whatsoever in the process of making these, whereas the mining process and uncovering natural stones is extremely expensive, takes a ton of water, is very polluting, and tears up a lot of ground.
Yeah, and just so we don't offend people, you know, a lot of those people have gone back in and reclaimed or basically
Reworked that area.
kind of like what they would do with a forest. I mean, you know, they don't go in and plant diamonds again or whatever.
No, but they are going back in. A lot of those places where maybe they've ceased operations and stuff, they've gone in, filled in, replanted trees and stuff like that.
But one place I know that they haven't done that is
the Kimberley mine.
Yeah.
Yeah.
Cause what do they call it? The blue hole or the
something like that.
And
South Africa.
Yeah, it's just
it's pretty much it's a really deep pit with some water in it.
A stagnant lake, which is bad.
Yeah.
It didn't really. I didn't notice the smell. Did we notice the smell?
No.
But it was kind of a greenish color instead of a nice blue color. They need to. They need to put some.
They need to put some fish and some.
No, they need to put
stuff in it.
Well, like some of these.
Let's chlorinate it. Oh, make it a big pool.
Some of these ponds or lakes, you know, they add food coloring. I'll say. To make it blue.
Yeah.
That's what they could do. Like they used to do.
Well, I don't think that's going to help. Really help. I think you need to get some wildlife in there.
Well, they're going to have to oxygenate it.
Well, so you put some algae and stuff
well,
in there.
I think that's what's growing is that green.
Well, then now you need to just throw some fish in there. Yeah.
Like some carp, huh?
Something.
Yeah. Well, they'd have to go down a long ways because it was a long ways to that water.
Yeah.
Well, then you're going to have some skydiving fish.
I don't know how deep. lower them down in a net or something, but, you know, because you just throw them in there, I think the fall would kill them.
Little parachutes.
Yeah, little parachutes. You just see all these little fish just, and they're little,
I wonder if they got any fish in there. They never did say, did they?
I don't know. That's a whole different story. Anyway, back to lab-grown diamonds.
Yeah.
So the process that is, you know, probably the most common with what we're getting is HPHT, which is high pressure, high temperature. And what this is like I said, we're recreating basically the Earth's mantle where the stones would naturally crystallize and form. And what's made this so difficult is over the years, you know, they've been trying to perfect this process, but in natural diamond, nitrogen, which is naturally in our atmosphere, and there's lots of it.
It seems like it's everywhere.
It's pretty much everywhere.
In fact, there's more nitrogen in the air than there is oxygen.
There is. Nitrogen actually, once it gets into a crystal structure and becomes a trace element, it turns those stones either yellow or brown. And the problem got to be is they couldn't control the atmosphere around the growing center enough to keep that nitrogen out, so they were typically getting yellow stones, and most of them like this. And, you know, where some people might find those pretty, they're not the most saleable. And so, ideally, they were wanting white diamonds. They were wanting colorless. And so the only way to do that was they had to figure out a way to control that atmosphere and get that nitrogen out. So more recently, they figured out a way to inject what they call nitrogen getters that go in and basically clean up the atmosphere.
Like little bitty guys.
No, it's not.
It's not?
No, it's not.
Like little robots. Oh, we're going to get this nitrogen. No,
it's not like that.
No, it's not.
No.
But we kind of figured maybe some of the stuff that they use. You know, I think there's a possibility that they use aluminum, and we're pretty sure that
they're using boron. Which in natural diamonds, boron can create color centers that causes blue. And so we have started to see some of these stones that are coming in that have what we call a blue nuance, that if they were natural would actually fall into the fancy color range. And so that's actually made a very interesting impact in our business because we've been able to sell some of these that actually have a natural blue color to them, but they're a lab-grown stone. Typically in like irradiated diamonds where they're trying to turn them blue. You have a little bit of a green tint to them. The color just looks a little bit funny. Sometimes they get super intense, and it's like, oh, okay, it didn't even look real.
Yeah, almost like they overdid it.
Yeah.
Or something.
Whereas these, and with natural blue diamonds, they have a real pleasing blue color to them. It's got real good transparency. It looks more like a natural color. It doesn't look induced. And so,
and this is all kind of from our point of view.
Yeah.
Because we've seen what natural colors look like.
Yeah.
And
then we have a real good comparison of the irradiated stuff because we see it a lot.
Yeah.
But these that have this blue nuance to them, so far what we've seen, they don't have a green modifier to them.
Right.
Which is what you will get in the irradiated. And the main reason you get that green in the
there
irradiation is because there's maybe some nitrogen, but also what creates green diamonds is radiation. And so you get kind of a mix there, and so you have that, if you're into art at all, you know that mixing blue and yellow will make green. Well, if you get a little bit of that nitrogen in there during this process, and then you mix in some of the natural radiation, or some of the radiation that's coming into that stone that normally would create green in a diamond, you get all that mixed up together, and you get this green overtone or undertone to that blue, and it doesn't look natural.
Yeah, it's almost like and I know this is not going to help a lot of people. It's almost like that not turquoise, but the blue zircon blue.
Yeah, a little bit. And I was going to see if we didn't have like maybe a picture of those.
I guess I could go pull a stone.
We had a ring over there that had them in there. Anyway,
let me see if I can go grab it.
I think she had a ring sitting over there that's got those in it. But anyway, with the lab-grown stones, yeah. So this is kind of that irradiated blue diamond. So this is a natural diamond that's been color enhanced. With the lab-grown stones, this looks a lot more natural. It looks more of an aquamarine.
Did you bring
yeah.
one that's got the blue nuance? It may be hard to pick up on.
Yeah, it may be a little bit difficult to see.
The only thing that kind of bothers me a little bit, maybe doesn't bother Colton much, is that whenever I learned how to grade basically white diamonds for color, is
you can't. You can kind of see the blue in there, but not a lot. It doesn't show up on camera well, but in person you can see this color.
So if it was a white diamond and we're going to grade it in one of the 23 shades of white diamonds or whatever, the possibilities of tinting or the other color in there is yellow, brown, or gray.
Yeah.
Okay, so this lab happens to grade these ones with blue nuance.
On that color scale.
Yeah, which
you can't do.
No, so if you get a little bit of blue, or you get a little bit of green, or you get a
basically
little bit
any other color besides those listed on that white scale,
it falls into the fancy colors.
Yeah.
So, it's just like originally whenever we saw these stones, we go, wow. It'd be nice if this was natural.
Yeah.
Because these stones would be considerably more expensive.
So to kind of give you an idea, we haven't really talked about price at all with these, but I guess we can kind of bring that up right now, maybe revisit it a little bit. But with these, because mine diamonds, because of their production cost and everything, they're still really expensive compared to lab grown, which it used to be, even just a few years ago, it was the other way around. And still, there are some instances. I know there's several stores that maybe the lab growns are still about the same price of natural. In some cases, they're still a little bit more.
Oh, really?
With ours have been averaging anywhere from maybe 50 to 60% of the price of natural. We've had some that were even lower than that. And so, like for instance, this stone that I just showed you, if this was a mined diamond and it was white according to the color scale that they used, which this was a GVS2 is how they graded this, so not considering that blue tone that's in there, mined or natural, this would have been a $9,200 stone. We have it for $4,900 as a lab grown. However, this is the kicker, and this is where that blue comes in. If this was a natural stone, then this would not be color graded on a white scale. This would be considered a fancy light blue. And so our estimation on this stone, where we're selling this at $4,900, and considering that they're saying that this is a white stone, if this was natural and on a blue scale, this is actually a $42,000 stone as a natural blue, which is pretty.
Is this
pretty
one
amazing.
This still got the same amount of color to it?
This is the one I just showed him. It's still,
This one is?
yeah. So
I don't know if that helps.
you
Yeah,
can kind of
see
see
it
the
a little
blue
better
in
there.
Yeah,
It's a little tough because the other thing that's nice about this grower is I've come up with a little formula thing to figure out what diamonds are going to look like before I actually see them by just getting some measurements and some angles or whatever.
their
So
proportions.
yeah, so a lot of these diamonds that we've got, especially the rounds, are like just incredibly cut.
Yeah, and so you bring that up. This is a 2.13 carat round. This is what we refer to as a super ideal cut. And so what he's talking about is these proportions are basically to the perfect scale, angle, and percentage needed to maximize the amount of light return. So these stones are having around 96% light return. So we're talking about light entering the top of the stone and being reflected back through the top. So what happens with that in this cutting is it actually causes these stones to appear larger than what they are. It's kind of like, if you imagine going down the highway, and during the day, if the cars coming at you don't have their headlights on, you can see the perfect outline of the headlight. But at night, they're coming at you, they got the lights on because they're really, really bright. You can't make out where the edge is at, so the lights appear bigger than what they really are.
Well,
and that's kind of what's going on here, but they are proportionately bigger too.
Yeah, I was going to say, and then the other thing is, a lot of diamonds, a lot of round diamonds are cut for extra weight, not beauty.
Right.
And these ones that we're basically buying from this grower are actually cut to be the prettiest
For beauty,
they can be.
not for weight.
Right.
Yeah. Which is a big benefit for you guys, because instead of paying for extra weight, that's like going to the deli and getting a brisket and it's all fat and a little bit of meat, but you're still having to pay for the whole weight. Or you can go and pay the same price or less for a brisket that's already had the fat trimmed, and you're just paying for what you're buying.
Right.
And that's pretty much what this is. They kind of trimmed the fat.
Mm-hmm.
You're only getting the primo part, and basically you're getting the brightest, prettiest, and most appealing stone that you can get out of that rough. Now, what's really, really nice is as this has gone on, and as they have improved the conditions in the area where these stones are growing, they have gotten to where not only are they whiter because of introducing these nitrogen getters that are cleaning up the nitrogen around where it's growing, where the crystal's forming, but they've also perfected it a little bit more to eliminate inclusions. The inclusions that are now happening in the lab growns now versus even just 5-10 years ago are far different. For one, there are far fewer inclusions in them now than what there have been in the past, at least with this grower. And the inclusions that are occurring in them now are more more like what occurs in a natural stone.
Mm,
You have feathers and crystals, but you don't have like 5-10 years ago you were having metal inclusions,
but
which were really common.
but some of the things that are in them still don't look quite natural.
Yeah, but they're a lot better now than what they were
Yeah.
even just a few years ago. Another thing is just a few years ago, we could pretty much easily identify a lab-grown diamond from a natural diamond with a simple UV test. Now, they've pretty much eliminated the fluorescence, and so they're getting harder for us to identify, but along with that, new developments in technology and formulas and stuff like that, there's new ways of detecting lab-growns. What's nice about all of these...
This one's easy to detect.
Yeah, these are actually all laser inscribed on the girdle that they're lab-grown with a serial number matching their certificate. And so real easy to identify there. But probably the biggest and best thing about these all around, and the reason why we've been selling so many of them, because we've been selling these, it seems like 10 to 1 over natural lately, is that their cost is
they're really pretty. Not that we
Yeah.
don't have mine diamonds that look like this,
it's
but
just
we don't have mine diamonds that look like this at this price.
at this price, yeah. And it's actually been really nice for us because this is really, really hard to shop too. It's a benefit for our store, but it's also a benefit for you guys because we're not taking advantage of this on you guys' part. We're taking advantage of the fact that we are being able to get this nice of stone at these prices and pass it on to you, and that these are even more rare than natural diamonds.
Yeah, that's kind of a little bit weird, I guess. But
Yeah,
if you take
it seems backwards.
if you take into all of the account of how many diamonds are actually produced, gem quality diamonds,
Natural.
natural and
Yeah.
lab grown, these are what, less than 1%?
Yeah. Lab grown
for the-
accounts for less than 1% of the diamonds that are in the industry. And so not only are these really, really pretty stones and rare in just their color and clarity.
And I guess the other thing we need to bring up, it's going to get to a point where this is not actually going to be true either. And that kind of sounds bad talking about this to begin with. But right now, there is no physical, optical, chemical difference between a lab-grown
and a natural.
And a mine diamond.
Yeah.
There are some differences, and people are starting to develop some instruments where we can
Detect those.
Yeah, because you get a stone that's smaller than a quarter carat. Very seldom does that stone get a laser inscription on the girdle because the girdle is getting so thin. So you get into small diamonds, which they're actually producing lab-grown ones. Right now, it would be difficult for us to tell those apart.
Yeah, it would. But you know what? The nice thing about this, overall, the nice thing about these are, for one, you are getting an actual diamond. A lot of people, this is one of the wives' tales that want to kind of put to bed here is that lab-grown diamonds are not diamonds. They're just look like. But if they look like it, they would be a simulant, which is what CZ and moissanite are. These are diamond in every right.
And CZ is cubic zirconia.
Yeah.
We get into these little initial things.
Yeah, but these lab-grown diamonds are diamonds in every right. The only difference between these and natural diamonds are origin.
Where they're born at.
Yeah. One comes out of the ground, one's coming out of a lab. That is it. Whenever it comes down to what's going to affect you most is price. For example, we showed you the one with a little bit of a blue nuance and kind of talked about it. But like this 213, if this was naturally mined, we're at a little over 52,000 for this stone, because this one is
That's all right. Just
I don't remember what the grading is, but it's extremely high, because all of these have been
high colors,
high color
class.
and high clarity, which is really nice. But as it is, this stone's 27,000. So
That still
That's
sounds like a lot, but once you see that diamond, I mean, it's impressive.
yeah, I mean, you're virtually half the price of a natural diamond,
Yeah, getting close.
and this one's going to be cut probably better than a natural diamond of the same size.
Mm-hmm.
You can get them close. There's going to be some that are maybe cut just as nice, but on average of what's out there
Oh yeah,
in this size,
Yeah.
the cutting alone puts these in the top 1%.
right.
Then you talk about the color and clarity. All of these that we've got are J and better in color and SI and better in clarity. That right there, across the board, natural
You
and
get-
lab,
you get-
top 1%.
Down to it, color-wise, for the most part, they probably average around an F or a G.
Yeah, all really high colors and high clarities.
And clarities are almost
We've had some
much
that were
BS.
we've had some that were internally flawless.
we've sold. We
So
sold what was it, a D VVS1, so it's one grade from flawless, and it was completely colorless.
yeah,
So,
so extremely nice stones, very reasonably priced.
Mhm.
There's no way that any natural stone of the same, if you're comparing apples to apples, color, clarity, carat weight, and cut, there is no way that you can get a natural stone for the price of a lab grown.
Right.
It's just impossible. Well, you could, but somebody's losing money on it, big time.
well, that or you're buying it somewhere else. I mean, as far as with us, that lab grown is going to be, I would say maybe a better value.
Yeah, it is. Like I said, we can only speak for our store. What's nice about the stones we're getting is we're buying directly from the grower. Most everybody else that I've talked about is buying basically third party from a cutter, and the cutter's buying from a grower. And so as that goes through, they're kind of picking up more and more costs, and by the time it gets to the store, there's either little or no difference in price between their lab and their natural diamonds.
And we're kind of guessing that's what's going on. It's just because
Yeah.
heard
from
prices of what they're selling.
Yeah, from the ones that we've talked to in other stores in the industry and in the areas, that's kind of the common thing, is they're having to buy kind of a third party thing, not being able to get directly to the grower.
But I think what's most surprising, because I followed these lab growns for several years. In fact, the first red lab grown diamond I saw in Dallas, and that was like I'm trying to think how long ago that's been. Probably 20 years now. I saw that just before it was unveiled to the media, I guess, or whatever. So, and actually, I guess the other thing was fancy colors were actually easier for them to do.
Yeah.
Especially
Yellows.
the yellows.
Yeah.
But even some of the other fancy colors were actually easier to do. I still think blues are difficult to do.
Yeah.
And probably the pinks, because a lot
And
of those
greens.
are. Yeah, and greens would be. And I don't know that I've seen a. Have I seen a lab grown green?
Well, I can show you a picture of one, because there's one in here.
I may have seen one at Vegas, but I was probably more interested in what was going on with the colorless. That lab grown one.
Yeah. We've got the green here, blue, yellow, and a deep yellow.
But just wanted to. The reason we're doing this is, I just think there's some other things
green.
that's kind of come up that we've learned about, especially the environmental things. I think where they're getting more efficient, what they've done is basically eliminated a lot of those environmental impact things. So
Yeah.
they can grow these faster. They're still not.
It's still not a fast process.
No.
But it's definitely quicker than trying to uncover larger stones in a mine. Because when we're talking, when we're talking about them moving that much earth and getting one total carat, we're also still not talking about gem quality diamonds.
Right.
We're talking about diamonds in general, and of those diamonds that are uncovered in that 1 carat, about 1% of those are gem quality. So if we're eliminating the industrial stuff and we're talking about just the gem quality diamonds that are coming out, the number is much higher.
I wonder how much of this is gem quality, because not everything they produce is gem quality. Never asked
Right.
that.
I think it's
'Cause
gotten
I know
more
they
efficient.
produce industrial.
Yeah. I know it's gotten more efficient with them producing gem quality.
Because that was what they're trying to do all along, was get to the gem quality.
Yeah.
Industrial is not a big deal.
No. And so, it's something that whenever we first discussed this about bringing these into the store, we were all a little hesitant because we're like, well, we don't want to sell synthetics, we don't want to sell these lab growns and stuff like that. We want to stick with natural, but after seeing them and seeing all the benefits of them, and especially seeing the price of them, it just didn't make any sense not to get them.
There for a long time, it just didn't make sense that you were. Why would you
spend more on something that was not even
Well, it's almost to me that you got two things that are virtually exactly the same.
Yeah.
The only thing the difference is origin.
And one's more expensive than the other.
Yeah. So.
And it was the lab grown then.
Right.
And now it's switched.
Right.
So now we're still like, well, why would you? But we understand the pull to have a natural diamond. It's natural. There's still an allure there. I don't think that it will ever go away. However, they are going to become more and more rare as years go on, unless there are new sources found.
But you get right down
unlikely.
to it, for the most part, mine diamonds are not overly rare.
No. But these are. Yeah.
But compared to demand, that's where the rarity ends up at.
Right. So, anyway, it's a really cool stone. There's a lot of technology behind this. They are basically kind of changing the market a little bit with these, and changing the way, especially engagement ring shoppers are looking at gemstones. And so, if it's something that you guys would like to know more about, or that you would like to check out, you can always stop by our store here at 4226 South Alameda in the Town & Country Shopping Center. You can always find us right here on Facebook, online at Susanns-Jewelers.com. You can always check out our Instagram page. We are constantly keeping that up to date and with new and exciting photos. And if you guys have any questions or you have suggestions of upcoming episodes that you would like us to discuss, then just leave us a message right here on this video. You can always check out our YouTube channel, and always reach us at 361-991-7565. So we thank you guys for joining us, and come stop by and check out these lab-grown diamonds. They're very, very pretty. Really hard to tell on this camera, but
video doesn't do them justice.
No, it doesn't. Even pictures don't do them justice. No. So come by, check them out, and learn a little bit about the technology and a little bit about the cutting and everything that goes into these lab-grown diamonds that are available now here at Susann's. So
thank you.
Thank you guys. Have a great week.